Hey everyone, so welcome to the course. My name's Sean. I'll be your professor for this semester in Pre-Calculus or Survey of Functions 2. So this is a class which might be the end of the ride for you, or it might be what you need to move on into the world of calculus. Either or, it's an exciting course. We call it a Survey of Functions 2 because this really dives into a little bit more in depth the meaning of what a function is, and then we just learn some cool functions in this, what we call the family or library of functions, that we can model different types of phenomena with. And so in particular, we're going to learn more about exponential functions and growth, which are, things that grow or decay in proportion to how much of the substance or population there is. So population is one example, right? The more people there are, the more people that will grow, and so that's what we consider exponential growth. We've seen exponential growth all over the news with the pandemic. It's a huge tool, and it's used in all different sorts of contexts. It's one of the most important functions in a course called differential equations, which you may or may not end up going to. But it is a key function. Anything that changes in proportion to how much of it there is considered an exponential model. We'll also look at logarithmic models. And these are the inverse to exponential functions, so it makes a good deal of sense that we'd look at them both. So logarithmic, essentially what it does is breaks down exponential growth into something a little bit more wieldy. So since it undoes the exponent, we can sometimes make a linear relationship out of something. It kind of flattens that explosive growth or explosive decay that we'd see with an exponential function. And they also have phenomena that they model themselves. So, while exponential functions might model population, there's financial models and situations. Logs are used in terms of natural phenomena like earthquakes, sound intensity, and as well as just solving exponential equations. So very useful unto themselves. And there's also some cool human developmental logarithmic models, like how we learn numbers is on a logarithmic scale, which means a steep growth at first and then slower over time. So it's a neat model to have in your back pocket. So exponentials, logs, we also look at trigonometric functions or periodic functions. So one way I like to phrase this is, there's three ways functions can change. They can go up, they can go down, or they can go up and down, right? So periodic functions are functions that oscillate, or they have a pattern or periodic repeating pattern that's tied to the circular nature or rotational nature of a circle. So things that repeat, things that fluctuate, things that oscillate, all can be modeled with trig or periodic functions. And they're really all just boiled down into sines and cosines, which you've heard from triangle trig, but maybe haven't seen in this context. This is a really cool unit. Anything with waves, anything involving electricity, magnetism, trig and periodic functions play a huge role. So if you're moving into that field, that will be something you want to keep your ears open for. And then the last thing we really look at is the rational functions, which are, again, rational means ratio, so comparison. So one function on top and another on the bottom. And how do they kind of race to the finish line? What does their long run behavior look like? So things like average cost functions. There's all sorts of great asymptotic functions that we can play with there. And back here to trig, things that fluctuate. So there's things like the tides. There's anything that's periodic in nature, heartbeat, etc. Lots of good stuff in there. Populations can also fluctuate, right? They don't have to just grow exponentially. And then the last thing we'll look at is the composition and inversion of functions. So once you have learned these 4 new functions to add to your library of ways we model the real world, we'll look at how do we put these things together in different ways, whether we be adding them, sticking them inside each other, and then inverting them, right? To look at if you have a certain perspective on a function, what would happen if we flip the input and output, and how would that give us a new look at this problem scenario? So it's pretty exciting stuff. It's not an exhaustive list. There are some functions that we don't talk about, but these are the ones we've identified as being really key to those of us moving on into calculus. So, and for those of us who are getting off the ride here, it was, intentional that you are familiar with these functions before departing this course. So that's just to kind of give you a frame of the topics we'll be looking at. Again, just like in our other courses here, we look at things from the 4 perspectives. And these are things that you're going to want to weave through the entire class for yourself, which are, which are graphical, algebraic, numeric or using tables, and verbal. Can we describe a functional situation? So, using technology for graphing, algebraically representing things by hand using symbols, representing a function via a table, or like I said, describing it verbally. These are things that you're going to want to weave through this whole course. I'll tell you right now at the top of this class that about 90% of the issues or questions that I get about a problem will be resolved by me moving you from one leg of this to another. So you might be looking at a problem. I really don't get what's going on with these symbols here. Something's not right. Well, have you tried looking at a graph, right? Or have you tried punching it into a table and looking at some values to make sense of it? Or have you tried describing it verbally? Or if you just have a verbal description, have you tried graphing it? Have you tried putting it into symbols? Usually looking at all 4 of these will elicit a solution or get you much, much closer to one. So I just wanted to share that here as well. So I'll be introducing myself a little bit more in depth in the class discussion, or the welcome discussion. So I'll get to know you guys a little bit more there. You get to see me more as a person. I wanted to jump right into the math here with this video. And in the next video, we'll be going through kind of the nuts and bolts of the course, how it's going to look, what you can expect from me from the class, and then what I'll be expecting from you all. So I will see you there. Enjoy, and welcome to the class.